Hi guys, this is going to be a recording about the project where I'll be explaining each and every codes line by line so that you have a better understanding on what's happening in the project and what code is doing, what action, and so that once you have a better understanding about the project code by code, then I'll be expecting you all to do some tasks. Uh, so let's begin. To start with, there are four files that I have created, py files. The first one is main.py, the second one is model.py, the third one is function.py, and eligibility.py. So these are the four files at the moment. I had started with one file, and then I splitted the functions and the models separate, and to make it more, to make it easy to understand and uh, for also the functions to run easily, make it less complicated basically. So I'll start with model.py. Okay, over here. uh, right, so let's begin with the basics first. uh, all of you all know what this window is. This is PyCharm. Okay, and inside PyCharm, I have created a project called BankBot. Okay, inside this BankBot, I have this my chatbot, which is a virtual environment. Inside the environment, when you actually install the requirements, all of this gets stored inside the environment, and the chatbot runs on this environment. Once you are all prepared with the chatbot up and running, and you have all these files, you'll be able to understand what I have done and the others have contributed for the project to reach to this level. Starting with this model.py file, um, if you can see, there are few libraries that we have imported, which is NLTK, Pickle, Random, NumPy, and then NLTK's corpus. From corpus, we have imported stop words, and then from stem we have imported word net lematizer, and from Kira's model we have imported sequential because we are going to make a sequential deep learning model, and then the layers inside the model. So we have imported dense and dropout. Okay, so along with this, what we are going to require is the optimizer for the model to run. So I have imported couple of optimizers, in fact, and after doing the R&D, I came to the conclusion to use RMS prop optimizer. Now, what these codes are doing, NLTK.download, they're actually downloading the files, which is this one, PUNKT, which is for punctuation. This is stop words and the wordnet. These files will be used while removing the stop words and then removing the punctuation or lemmatizing the words. So wordnet lemmatizer over here, I've made an object from this uh, library that we, or the class that we imported above. Okay, so this is the first function. What it does is word. Let's say, I mean, it's the name is word cleaning. What it does is it cleans the sentence, or organizes the sentence into separate words, and then it processes for the in the form of lists, so that these lists can be used to make a training file. Okay, so to make it less complicated, what I'm going to do is I will go ahead and show this function in Jupyter Notebook, wherein you can understand how this file or how this function works. So let me open the Jupyter Notebook. Okay, not this one. Okay, so here we have this file here. Okay, so we have this the same file in Jupyter Notebook. Okay, these are the things where we just saw. Okay, what we have imported uh, and downloaded. Now, a couple of things over here. I have removed it in the main file, which is not getting used. So to start with, what I did is I created three separate lists, empty lists, words, class, and documents. Now, what we are going to do with these empty lists is we are going to fill them with different types of inputs. Now, in order to fill this, we first need the inputs. So we have actually we created a file called intents, which is in the JSON format. Okay, and this JSON format is basically, if you know how the dictionaries are there in Python, JSON is exactly the same. It is a dictionary format. So I'll take you back to the JSON file, which is intent, wherein you can see this is how the file looks. The entire thing is inside one curly braces. Okay, starting to the end, everything is under the inside this curly braces, which is a dictionary. And then we have one keyword. Okay, and the value to the keyword is inside the list. So there is one keyword and there is only one list. Inside the list, there are more dictionaries. This is the first one. So if you can see, the first one ends over here. From the curly braces, it starts and it ends with the curly braces. And inside this first dictionary, there are a couple of keys and values. The first one is tag, and the second one is patterns, third one is response, and the fourth one is context. Now, what these are going to do is the patterns will have all the conversation that a user can do, but we have divided the conversations in tags. So in this one, the first one, which the name of this tag is greetings. Inside this greeting, the dictionary where the tag name is greeting. Inside this, the patterns will have all the types of greetings that one user can give it or say to the chatbot. So if there is any such sentence that comes from the user to the chatbot, then the chatbot will run its model to check where are these words, and it will find the words in this first dictionary. The name of the dictionary will be the tag, which is greetings, and then it will uh, respond from one of these in the respond column. So the response uh, keyword has a list. Again, inside the list there are sentences, which is going to be the response of the chatbot. This is how the the architecture is. This is how the concept of responding is. So every time you give a sentence to the chatbot, it gives you a reply. And how it gives you a reply? It gives you a reply with the help of a model, which I will talk about it later on. So with the help of the model, what the model does is finds this sentence of the user inside this intent file, because there are a lot of dictionaries. There is a thanks, there is one which is default fallback, and there is one which is help. So if the user says, what all support can you offer, or if the user says, what can you do, or how can you help me, if any of these sentences come from the user's end to the chatbot, the chatbot will take the sentence, run it in this file to see where it matches, and the closest match, it will find what the tag is for that. And with the help of the tag, then the model will find out in this particular, where this tag belongs to, and wherever the tags belongs to, from there the response will be picked up, and any of this response randomly will be thrown on the screen. So this is the concept or the architecture of how the chatbot is responding. So how this model was made. Okay, so let me get you back to the model. Now, So in order to make this model, what I did is I created three empty lists. The first one is words, the second one is the tags, which is called classes, and then the third one is documents. Okay, so what I'm doing here is I just took the intent file, okay, which I will put it now. One moment. So I have this intent file here. Oh, oh, what's happening? Okay, so yeah, it's the runtime is getting initialized, so we'll have to wait for a second. Okay, now it's done. Um, then I will take the intent file and upload it. So I'm using Google Colab. If you people might be aware of this, if not, then this is Google Colab, which is on the browser itself, where you can use with the help of your Google email address. And one more thing, guys, I understand that this is going to be a little long. This recording is going to be for an hour, so you might get bored listening to it, or I may get stuck and I'll be, struggling with things. You might be watching that and getting even more bored. But this is for your own good. So if when you're looking at the recording, when you're watching this recording, uh, you can fast forward, okay, things where there is gap, and try to complete this or understand whatever I've explained in this. Okay, so yeah, so I just uploaded the intent JSON file, and I'm going to run this. So to do that, I will comment this out because I'm not taking the FAQ data. I'm just taking the intent JSON to show you all. Okay, and I'm running this now. I think I forgot to run the first one. Okay, so let me import all the data, all the libraries, and then run the words. So I got the intent JSON file in the uh, variable called intents. Okay, so I'm not going to run this one because it is for the FAQ data. So in order to check what is in this intent now, how this JSON file looks over here. So if I just simply type intent and with a square brackets inside this, the keyword which is intent. Now this keyword is over here. This is the keyword. Okay, the name of the file is also intents, and the keyword inside is also intents, so don't get confused. So this is the name of the file. Okay, I just gave the name of the file as intents itself while loading it. Okay, the original name of the file is intents. Then I opened the file into data file, and then I loaded the JSON file, which is the data file, and named it intents again. So in order to access this every time, now I will have to type in intents and then the square brackets with the keyword. When I type the keyword, then I am supposed to get the value. The value is the entire thing which is inside one list. So entire thing is one value of this keyword. Inside this list, which where you can see the square bracket, okay, it starts and ends with the square bracket. Inside this, there are a couple of dictionaries. Now each dictionary has tags, patterns, response, and uh, context. The context set and context filter is, I'll talk about that later when I'm explaining the context. Right now, I just concentrate on the tag and the pattern and response. So this is what I will get. Okay, this is what you will get as intent uh, file. So what I'm doing with this file is I am actually using a for loop to go through the file, wherein I say for intent in intents square brackets the keyword intents. Okay, this will actually pick up each dictionary. So in intent now, when the for loop runs, it is picking up each dictionary. Now inside this each dictionary, again I'm running a for loop where I'm saying that pattern in intent patterns. That means in each dictionary, which is this intent, there is a pattern keyword. So I am looking into that pattern, and those whatever sentences are there in that pattern. Say for example, if the for loop is, it's going to go through all of the uh, intents, which is all of the dictionary. So I'll just pick up this one to show you an example here. This one, this dictionary starts and ends over here. It has pattern, and inside the pattern there is nothing. Okay, so whenever I get nothing from the user, or if let me put it across in a better way, whenever I get a sentence which is not there in this entire file, in this entire JSON file, something that the user said and which is not there in this entire file, then the model will pick up this tag, which is default fallback, and give out a response from one of these. There are responses are like this: I didn't get that, can you say it again? I missed what you said, what was that? Or sorry, I didn't get that, can you rephrase? These are the sentences that the chatbot will respond. In other cases where the pattern is there, like for example this one from the tag, which is thanks. Okay, in this, if the user says thanks or thank you or that's helpful or awesome, thank you, or all these kind of words which are used to thank someone, then in that case the response will be with this: hi, how may I, no, not this one. Response will be happy to help, or anytime, my pleasure, you're welcome, or welcome. So these are the response that will be uh, coming. But right now what we are doing is we actually pulling out all the patterns from all the dictionary, all the patterns, that means all the sentences that the user will say in each and every tag by this for loop. So this for loop, what it does is it picks up all the patterns, that means all the sentences in each pattern of each dictionary. Okay, and then what it does, one by one it will take one dictionary, and from one dictionary it will take the pattern, and that pattern will be tokenized. So we are using NLTK word tokenizer over here, the function, to tokenize the pattern. What does this tokenizer do is it actually splits the sentence into separate words. Okay, so like this, see. So let me show you how it works. So for example, if I had to tokenize a sentence, I'm just going to use this to show you all. And I have a sentence here. Say for example, this is my project. And if I run this is how it gets split. This, and then another word is my, and then project. I hope you got the idea of what this word tokenizer is doing. In the same way, there is something called sentence tokenizer, in which you put the entire paragraph and then it splits into separate sentences. This is word tokenizer. So you just put a sentence into this, and it splits the sentence into separate words and then puts into a list. Okay, like this in the square brackets. So I'm going to delete this. Okay, and let's go back to the function here. So in the text token, now I get the list of words of each pattern. That means in every pattern there are a lot of sentences, uh, as we saw earlier here. Like in this pattern of by, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sentences are there. Now sentences can be a single word also, or a couple of words as well, as long as they are separate items here. Each one will get distributed into words, and each one will be like each item will be a list now. So now what I'm doing is taking this text token, and with this for loop again, I'm trying to check if any of these words are in the stop words. The stop words, where did we get this from NLTK download, when we did this, the download that we did in the beginning. Okay, see here. So when we use this one here, okay, this, from this where we get the list of stop words. And now what I'm doing is I'm checking the text that I've split. All those words which are in the stop words, I don't want them, so I'm removing them. So I'm putting them into a different variable where I've named it token without the stop words. So now I have words which does not have the stop words. Now what are stop words? Stop words are the words which are like and, the, a, of, for, is, this. All these words I do not want it. I just want the main words of the sentence. So I've used token without word, and I filtered that out with the help of this for loop. And then I'm after filtering that, I'm putting the remaining words into the first list, which is words. I'm putting everything into the first list. So every time the for loop runs, it actually picks up a dictionary, and inside the dictionary it searches for the keyword pattern, and inside the pattern what all things are there, it tokenizes, and it filters from stop words and puts into the word list. I hope I'm clear till now here. And then the next thing what I'm doing is, inside the document list, what I'm doing is, there is I'm putting the same words but along with the tags. So each dictionary also has tags, and the name of the tags are different. So each time when I'm running through each dictionary, I'm making a list of words in that patterns, in the keyword pattern, and then I'm besides that I'm keeping the tags. This is how it gets stored in the document. Okay. And if you want to see how it actually gets stored, if I just print first, I'll have to run this. Okay. And then I run the document, and if you can see inside the document, this is what is happening. So bye bye is one sentence, which is divided. It's not getting divided because it's like connected with hyphen. If I look at the other one, okay and bye, okay, was one sentence. It got divided into two, and that too in a list, and besides that is the tag name, which is goodbye. So in this way, this is how the document list will look. This is how I made it. And the reason I'm making this is because the first part, which is this list of the words, okay, the first part, which is the list of words. Now if you look at the bigger the sentence, the list is bigger. The first part where there is a list of word, and the second part is the tag. Okay, I chatting regarding late payment dot. So entire thing is in the list, which is first part, and the second part is charges and fees. Why I'm doing this is because when I'm going to use this data into a model, I'll be using the first part as the X and the second part as the Y, which is the label. The first part will be the feature, which will be the input to the model, and the model will check where this input belongs to, and it will give a tag out, which is where the sentence belongs to, and whichever tag it belongs to. And once we get the tag, then with the help of the tag, we will search that tag inside the intent.json file, and then we will pull out the response from that particular dictionary where the tag belongs to. So this is the idea. So let's go back here. So in this document list, this is what I'm saving, wherein two piece of information is getting stored. The first piece of information is the list of the words in the sentence, and the second piece of information is greeting. And then what I'm saving in the last list, which is the class, I'm simply saving the tags. Okay, so each time in this for loop, the for loop is picking up each dictionary. Each dictionary has patterns and then tags. Okay, so we are using the patterns to make a list of words and saving it in words, and at the same time we are using all the tags to be saved in class list, and both together in documents. I hope you have understood till here. If you haven't understood, you all can rewind and listen to the conversation, listen to the explanation again. Now, next, what I'm doing is with the help of Lematizer, I am lemmatizing all the words in the word list. Okay, and then sorting them. Now, what is lemmatizing? Lemmatizing actually searches for the root word of your word. So, for example, if your word is uh, going, which is G-O-I-N-G, the lematizer will search for the root word, which is go. If there is a word which is walking, then the lematizer will search for the root word, which is walk. So in this way, all the words will be lemmatized, and only the root words will be kept inside the word list. Also, the ignore words, which is the punctuation part, I have used the ignore word list, which is over here, in order to remove all these ignore words. Okay, so let me put another one over here, which is full stop. I don't want the full stop as well. So when I run this, now I get a list of, if you can see the result here. So what I've done here is I've taken the words lemmatized, sorted, and then classes also I've sorted. And I'm printing these things to check. I have got inside documents, I have got 106 entries. Inside the class, there are 15 classes. That means there are 15 tags. These are the names, charges and fee, company name, date of birth, foreclosure, goodbye, greeting, help, loan application status. So these are the classes or the tags. And then 112 unique lemmatized words. So out of the number of words that we actually get, these are the unique words which the lematizer could find. Out of these, many of them are numbers which are in the string format, because it's in the sentence, and then rest are the unique words like application, apply, appreciate. All these are in sorted in ascending order, alphabetical order. Once I do this, okay, I convert this entire thing, which is this entire code, into a function, wherein I will just give the function this intent file, and the function will give me these three files, which is word, class, and documents, three lists, which I needed further to uh, to uh, do the processing, or to make the training data for the model. Okay, next we will going further. So this is how I have named the function word cleaning. I'm giving the intent file, and in this function now, whenever I give the intent file, it gives me three files, which is document, class, and words. In the next part of the section of the model, how I'm preparing the training data. Okay, over here I just created an empty list again, which is training, in which all the training data will go. There's another list that I've created, which is output empty, which is uh, which has only zeros, a list of zeros, which is with the number of depending on the number of classes that we have. Now I just saw the number of classes that we have is, if you can see, uh, one moment, let me run this. We saw that there are 15 classes. Okay, so when we have 15 classes, okay, so what I'm actually doing in that code is, uh, over here in this variable, which is output underscore empty, I am just simply multiplying a list of zeros with the number of classes. If I just do that separately and show you all what is exactly happening is this. So if I take a list which has only one zero, and if I multiply this by the length of classes, which is actually 15, then this is what I will get. I will get a list which has 15 zeros. Okay, this is what I'm making here. So I have a variable in which I have 15 zeros, and zeros depend each time depending on the number of classes, because the classes keep on changing as in when I keep on adding the new intents, new conversations to the intent JSON file. Now, what I'm doing is I'm taking the document file, document list, which we just created above, and I'm using a for loop. Inside this, each item in the document list is having two different items inside that. First one is the sentence, which has been tokenized into words, and the second one is the tags. So I'm creating an empty list which is called bags, in which I'm going to put all the sentences in the form of list, in the form of zeros and ones. How do I do that? I have taken the first item in the for loop. It will take each item in the document. Each item has two parts, so I'm taking zeroth index, which is the sentence part, and one the first index will be the tag part. So for the first part, which is the sentence part, I'm putting it into another variable called pattern words, and then I'm lemmatizing these words. Okay, and how I'm lemmatizing the words, uh, just with the lemmatizer. Each word inside the pattern word is first getting lemmatized, and then I'm using the word list with the for loop. Now in the with the for loop, what I'm doing is I'm saying W in word list. That means each item in word list. What I'm doing is I'm checking if any of the word is appears in the pattern words. If any of the word appears in the pattern word, then I'm going to fill the bag with 1, or else it will be 0. So say for example, if this word list that we are using, which we created with the help of all the patterns in the intent.json file, and we removed all the stop words and we lemmatized it and all that stuff, and we found about there are 112 unique words. There are 112 unique words in this file, and we are checking each one now. And with the first sentence in the document list, uh, which we stored in the variable pattern words, we will check if these words appear here. So if these words appear here, we will mark them as 1, and rest will be marked as 0. And this will be the first list of 112 digits, wherein couple of the digits will be 1 and rest all will be zeros. I hope you get this. So this is when the for loop runs, for each entry in docs there will be a list that will get created, uh, wherein which is the list will be named as bag. Okay, in this everything is getting stored. So this bag will have 112 digits every time, and out of which couple of them will be 1 and couple of rest of them will be zeros. Okay, and then the rest, what I'm doing next is with the output row we just created, the output empty list that we created, which is of zeros. What I'm doing is over here also I'm checking uh, the second part of the document, which is D1 document doc1. Okay, where it is, here it is. So if this appears in any of the class, then that will be marked as 1 and rest will be 0. So there are 15 class. That means every time when the for loop runs, it will create a list like this. The first list will be of the sentence. Okay, if you can see, the first list is of the sentence, which has 112 uh, digits, and out of this only one is 1, because the first one is for the hi in the greeting. There's only one word as hi, and then the rest are zeros, and along with that is the another list which is for the class, which is 15 zeros, and out of 14 zeros, and one is marked as 1 because there is only one class. So basically this is the same thing which I just converted into zeros and ones, which you earlier saw over here. Okay, so over here if you can see, there are only two words and only one. Obviously the tag will be always 1 where it belongs to. So these two words out of 112 will be marked as 1, and rest 110 words will be marked as 0. And for the tag there will be 15 digits, out of which only one will be marked, whichever is the goodbye tag, it will be marked as 1 and the rest will be zeros. So I hope you got the idea of how I'm creating a vertex and the training data. So the first one is your feature and the second one is your label. In this way, when I created the created the training file, I use the entire data, which is this one, the entire